Okay, so we're going to be doing classwork number 12, negative and zero exponents. So before we get to the problems on the left-hand side, let's actually talk about these rules that is going to be guiding us through the process here, okay? Let's first talk about the product and the quotient rule. We're not going to really see the product rule in play in this specific worksheet. It's actually going to be in the previous classwork, but I'm going to briefly mention it. Obviously, if you have the same base, in this case, it can be 2, 3, 4, right? If I have 2 as my same base, right, in the same color, it doesn't matter what my exponents are. My exponents can be 4 and 5, 4 and 6, 3 and 2, um, 5 and 3, right? The key is that as long as they're the same base and they're multiplying. Once they're multiplying, it would end up looking like 2 to the 5 plus 3, giving me 2 to the 8. Okay, 2 to the 8. So 5 plus 2 is 8, so 2 to the 8. And that's product rule. I have explained it in more detail in our previous worksheet. But let's talk about the quotient rule. The quotient rule, and notice product is multiplying, quotient is dividing. So if I end up adding my exponents, quotient rule, I'll be ending up subtracting my exponents. So if I have the same base, which is 2, right? And they're being divided. It doesn't matter what my exponents are. If I had 4 and 3, right? 5 and 2, so forth. The thing is, as long as I have the same number that's dividing, same base, the blue, as long as that's the same and I'm dividing, the quotient rule states, hey, you're going to subtract these exponents. Okay? Let's subtract the top from the bottom. 5 minus 2. All right, that's how that works. If you ever ask the question why, right? I can kind of explain this in detail. Okay? 2 to the 5 is the same as 2 times 2 times 2 times 2 times 2. That's 5 2s, right? That's what 2 to the 5 means. And if I'm dividing this by 2 to the second, right? Which is the same as just 2 2s, right? What is 2 divided by 2, right? It's just 1, right? So you have a session that's they're just canceling each other out until 1 runs out. And I'm left with 3 2s on the top, which is the same as 2 to the third or 2 to the third. Okay. And what's on the bottom? 1. I would write this, but that's redundant. Okay, so it's 2 to the third. And that's why the quotient rule works the way it does. Even though I'm dividing here, it does feel like I'm subtracting 5 minus 2. See, there's 5, there's 2 on the bottom. I'm left with 3 on the top. Let's talk about the zero rule. Okay, now the zero rule says, hey, if I have anything, doesn't matter what it is, anything raised to the 0, it ends up being 1. So if I had 2 to the 0, 1. If I had 10,000 to the 0, 1. If I had a random number, if it's raised to the 0, guess what? You have 1. Even if I raise other letters, if I had raised b to the 0, it doesn't matter what b ends up being. If it's raised to the 0, it's going to end up being 1. And say, wait a minute, this sounds a little counterintuitive. How come x to the 0, anything touched, 0 touches, don't you get like, 0? Well, let's use the quotient rule to explain the zero rule. Okay? So let's just say that we have 2 to the second divided by 2 to the, let's say 2 to the third divided by 2 to the third. Okay? Let's expand this, right? Well, before we expand it, let's actually use the quotient rule. 2 to the third minus 3. That gives me 2 to the 0, right? So now let's expand it. So 2 to the third on top would be 3 twos multiplying. And then 2 to the third on bottom would be 3 twos on the bottom. Now, if we cancel each one out, right? 1, 1, 1, 1, 1, 1, right? I have nothing but 1 on the top and 1 on the bottom, which ends up being just 1. So that's why 2 to the 0, anything really to the 0 is 1. Okay? So that's why the 0 rule works the way it does. Now, let's talk about the power rule. Okay? The power rule states, hey, let me just move this down a little bit. The power rule states, hey, if I have a number, right? A number, any number, right? If it's raised to an exponent and then again is raised to another exponent, this is the only time where you multiply the exponents. X to the n times m. You might even see a textbook that'll say x to the m n, right? That's the same thing. So if I had, for example, 3, right? 3 raised to the second, and then I raise this to the fourth, right? This is the only time you multiply the exponents. See? And then 2 times 4 is 8, so it's 3 to the 8. Okay? So, if you wonder why this multiplies, right? Let's expand this. What is 2 to the second? 2 to the second, if I were to expand this, is 3 times 3. Now, that's within the parentheses, right? But if I raise this to the 4, that means I'm going to repeat that 4 times. So 3 times 3, and then 3 times 3, and 3 times 3. Okay. So how many 3's do I have in here? Right? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 3's. Okay? Or 4 groups of 2. Okay? So that's the same as 4 times 2. And that's why it ends up being 3 to the 8. Okay? That's how the power rule works. And one more rule to go over here. The negative exponent rule. The negative exponent rule says if you have anything raised to the negative exponent, to make it positive, you're going to have to put it under a fraction. Okay? Not under a fraction, but make it a denominator for it to be positive. So if I had any number, let's just say that I have 5 raised to the negative 3, then for it to be positive, it's going to be 5 to the third. Okay. Vice versa. If I happen to have 5 to the negative third on the bottom, right, then it would go on top. Okay. Say, how does this work? We're going to use a quotient rule to explain the negative exponent rule. Okay. We're going to use the quotient rule. So if I had, for example, 3 to the second divided by 3 to the fifth, or let's just say 3 to the sixth, right? And I were to expand this, right? Well, before we expand it, this would be essentially 3 to the second minus 6, which is 3 to the negative 4, right? Well, if I were to expand it, if I had 3 to the second, which is 3 times 3, right? And then on the bottom, I have 3 to the 6, which is 3 times 3 times 3 times 3 times 3 times 3. Then they cancel each other out, right? 3 divided by 3 is 1 until one of them gives out. How many 3s do I have in the bottom? I have 1 just left on top, right? I have 4 3s on the bottom. 4 3s on the bottom multiplying each other is the same as 3 to the 4, okay? So do you notice that 3 to the negative 4 is the same as 3 to the 1 over 4? So that's where the negative exponent rule was born. 3 to the negative 4, same as 3 to the 1 over 3 to the, no, 1 over 3 to the 4. Okay. Now that we have covered our rules, let's go ahead and apply this knowledge to our problems. Okay. I'm going to have to write these rules so that you see how these rules are applied as I do them. So if I have x to the 6, so if I have x to the 6 divided by x to the negative 2, the quotient rule is going to be applied. Okay. So the quotient rule states, hey, if I have two things that are dividing, right, I'm going to subtract them. Okay. Just going to write this over here right quick. So I have, now pay attention to this subtraction sign here, okay? So this right here, this subtraction sign. So I have x to the 6, right? Minus what? My n. My n happens to be a negative 2, okay? And so even though I'm subtracting, this is going to end up being a positive. So this is going to be a positive. This is going to be x to the 6 plus 2, x to the 8. All right? So that's how you handle that. Now let's go to our second problem. Okay? We're going to be doing the quotient rule, right? Then the negative exponent rule. Okay, so quotient rule first. Again, I have to have the same basis. So you notice h does not have anything on the bottom here. There's nothing on the bottom that has h. So we're not going to be doing quotient rule with h. We are going to be doing quotient rule with a. So remember, my quotient rule is anything that's the same, I subtract them. Right? So a to the negative third, which is on top, right? Minus 3. What is negative 3 minus 3? It is negative 6. Okay. Now, I'm not going to do my h. Well, actually, I am. I'm just going to rewrite my h. Because I can't do anything with it. Just rewrite it. Now my v's. V to the 7 minus 5. Okay, see that minus there? Okay, what is 7 minus 5? 2. So am I finished? No, I'm not. I am not. I'll be doing the negative exponent rule, which says, hey, if I have something raised to a negative exponent, it's going to end up on the bottom, okay, as a positive exponent. Well, what are my negative exponents? I have my a is raised to a negative exponent, and I have my h is raised to a negative exponent. So my next step is to put them on the bottom, which I have to have a fraction bar for this. What is not a negative exponent? Just simply carry it over to the top. So v squared, and then the a goes in the bottom, a to the 6, and then the h to the, now do we have to write 1? No, we don't. We definitely had to write -1, but we don't have to write 1. And now we are finished. This is the finished product. Okay. Let's go ahead and move to another problem here. Let's talk about this one. Okay. Now, the first rule that we're going to apply is the power rule. Okay. And by extension, the power rule expanded. Okay. Because I don't have, when I have x raised to the m raised again to another exponent, the example that I showed you is I only had one letter in there. But if I had more than one letter, whoops, let's just say that I had a to the x and then to the 3, x to the m. That means that this whole, everything is affected that's in the parentheses, okay? This n, or whatever exponent is here, is going to multiply to everything. That's the power rule expanded. So we're going to do with the power rule expanded, okay? It's going to look like 3 times n, and then x to the m times n. So that's what we're doing here. Since we're doing the power rule, and it's best to do one rule at a time. Don't try to do more than one rule on a step. You're going to just mess up. Since we're doing the power rule, we're just going to rewrite the top. So d to the 4, k to the 3. Okay. Now the bottom. This 0 is going to be multiplied to these exponents. So d to the -9 times 0, right? You see that? What is -9 times 0? 0. And I'm just going to erase this right here just to keep this clean. All right. Now next, k to the 11 times 0. What is 11 times 0? 0. Okay. Now I'm done with the power rule expanded. The next rule I'm going to apply is the 0 rule. Okay. The zero rule states that if I have anything raised to the 0, it is 1. So my next step, I'm not going to touch the top just yet. Right? D to the 0 is 1. K to the 0 is 1. 1 times 1 is the same as 1. Okay? All right, so that's applying the 0. And then last, I have to do the negative exponent rule. Okay? So, again, if I have a negative exponent, it will be positive on the bottom. So what are my negative exponents? Well, just as D. Okay? So this d is going to be ending up going to the bottom here, okay? So my next step is uh, rewrite the top, k to the third, because I didn't move k down there, and then d to the positive 4 on the bottom. So what happened to the 1? Well, d to the 4 times 1 is the same as d to the 4, okay? So no need to write that. And this is your final product, okay? So I just did 3 problems. You should be able to be equipped to do the rest of the problems.